Okay, so I'm also here now for a lightning talk for 10 minutes. So I will bombard you also with some slides in these 10 minutes. It's about what I learned from retro microcontroller and my experiences with RTL programming. Not always as I like them to be, but so what I did is I had the crazy idea to make my own custom ASIC chip. And always people say it's impossible, but I don't think it's impossible. What I was planning to make a chip with open source cores with the Motorola 68000, the Z80 and a MOS 6502 on them. I combined them because it's, from logistics points, better to put it on one chip than having 3 different chips, but that's it has some features with 4K on-chip RAM, IOs, and maybe some peripherals. But I tried to limit the features to be able to know that when the chip comes that it works and that you don't have a non-working chip, because then all the money is lost. And then I also planned to have some boards that were Arduino type boards that would be compatible with these instruction sets. I'm not going into detail. If you want to know more about this retro microcontroller, you can go back to the retro computing dev room of last year, and there I have explained in full detail. So I did a crowd supply crowdfunding, and you see I didn't reach my goal. I only got $4,000 of $22,000. It's a pity, but the nice thing is, of course, that none money has been spent. I didn't have to invest anything, so I know now that I need to work on more things. So when I did this, I also followed several online fora to see what the people think about it. What I tried to do is combine this retro computing with Arduino, and it seems that this combination doesn't really make anybody really want to go for it. So an Arduino guy says, yeah, it costs more than Arduino and it has less features. They just want to run their sketches. They don't mind if it's a Z80 or a 6502. They just want to run their sketches. Of course, I'm exaggerating. I'm putting it black and white, but that gets the message across. Then you have open source guys. There were several guys who said, "Yeah, it's nice what you're doing, but I'm not really looking for an Arduino board." So yeah. And then you have the retro computing guy. He says, "Yeah, but you don't have a memory bus on your chip. I cannot do anything with it. I want to put it on a board and have some peripherals." So because I only planned IOs. So then my next step is why I wanted to have not too many features is to be able to first time write. But this is kind of, and then I go further is, and the reason that you want to limit the features, in my opinion, is that actually the RTL tools, the HDL and Verilog, are not the right tool for the job, in my opinion. So what are the main RTL faults I see is, for example, they say a clock is like any other digital signal. Only we look at the rising edge and the falling edge. But you define it as a logic signal. So also, the first thing when you notice RDM is that you have to learn that you know what is being inferred when you write something. If you write an if statement, it can be either a flip-flop or it can be a mux. In itself, that's not a problem. The problem is that you have to know when you write it that is the case. If you would have the right abstraction level, you should not have to take care. You should only think in if statement and not in flip-flop or mux statement. So that to me is one of the fundamental problems that we have now with RTL. Also, then you have this crazy idea of you have your language and only a subset of that is synthesizable. The rest is non-synthesizable. Which also to me is, I'm coming from the programming side, I could not understand this, why it's the case. In the end, I learned that actually these have evolved of trying to simulate the reality, and it's more developed to be simulating. Also, the blocking versus non-blocking statement in Verilog here is an indication to me that it's not the right abstraction level. Everything is parallel, but then an assignment can block everything, which is not right to me. And then also you have FPGA versus ASICs. If you have something working on FPGA, it doesn't mean that it works on an ASIC. And then read the fucking language reference manual. If you go, if you go then on these sites, these are professional tools for professionals. You get bombarded with in section 3.5.4.1 of the language reference manual. It says this, and if you don't know the language reference by heart, you're not a good RTL writer, I think. Some people think like that because it's a commercial and tool. So some would be solutions. Yeah, of course, the languages have evolved over time. They have added some nice features like combinatorial generate statement, record interface. But in my humble opinion, they don't fix the fundamental problem. To me, it's more lipstick on a pig than not truly, of course. You also have transaction level Verilog, which is now promoted by Redwood VDA. They try to extend it with to writing pipelines in URL code easier. But also, again, this doesn't solve the problem to me. Then you have system CTLM, which is event-driven. You have also transaction level modeling. This is an example. But when I look at how an AND gate is implemented in System C, it doesn't really give the indication that it has any improvement over the RTL languages in that respect. It's already some time ago that I looked into this, but to me, going from the transaction level model to an event-based model, you need to do that manually. There are no good automated tools, or they are commercial, as far as I know. Then you have systems C, C++, System C as your electronic system level design. Most of the time, the good tools are now proprietary. You have Vivado, HLX, Catapult. Synopsys also has their own. I would love to see more development on Panda Bamboo, which is actually an open source tool who does this. I also need to investigate Goat more. But then you need to register before you can download, which is for an open source guy kind of already a first hurdle to take. I think this would be nice to have, but it's not a good fit for implementing something like a retro microcontroller. Then you have MyHDL, which is an HDL, is a Python syntax for doing, but it's based on the same event-driven principles as RTL. So in my mind, that's not going to solve it. But the author has a different opinion. The Kaluwe has a different opinion. He really says that he wants to be event-driven in his language. So what I found 3 languages which are going to me in the right direction. You have Chisel. Some people who know RISC-V probably know about Chisel. It's the MIT guys who developed the rocket core of RISC-V in Chisel. And then you have Spinal HDL, which is a similar but a language. I tried to go into both. For me, Spinal HDL seems to be a little bit more intuitive than Chisel, but that can just be me, of course. They're both based on Scala, so that was one of the problems I had, is that I wanted to go further into Spinal HDL, but once you get an error, you really have to know Scala also to fix that error. It's nice up to a point, but there's certain what you need to know. And I was then, in the end, I decided to go for MiSoc, which is a Python library, an hardware that does the same thing. But it's under big development because they now stopped developing the MiGen, which is the first version, and now working on NMiGen. I'm a Python guy, so for me it seems to be a nice fit. But all 3 things I given here are, I think, a good thing. So, and I want to go to the last slide. This is good. This is the first step, but I want more. And to me, one of the big things that are missing is that you need to also be able to compile and debug on your level that you're writing things. If you do Python, you debug in Python. If you do Java, you debug in Java. And for these tools, most of the time what they do is they generate Verilog or RTL, and then you have to do the debugging RTL level. or yeah. So I think Fertile, which is the lower language for Chisel, you can do debugging on Fertile level. Meegen can simulate on Python level with some restrictions, but to me that's one of the things to solve to get everybody doing hardware development. Thank you.
Questions? Have you compared the licenses of those solutions that you're mentioning here?
The question was that if I compare the licenses, actually I only restricted myself to things which are open source, so either permissive or GNU or what's it called, copyleft type licenses. I prefer copyleft type licenses, but I didn't. The only problem was maybe with System C in the beginning there was some problem with the license, but I think they solved by going to the Apache license or so. Yeah.
Any other questions? Can you say some words about the gadget you're using for giving the presentation?
There is Pi on the case, so it's just a Raspberry Pi. Yeah. And some wireless keyboard. So this is my AV system at home where I watch movies. So.
Whatever language the community settles for has to somehow bridge the gap by going to Verilog or HDL and at the end of the day to be able to tape out.
Yeah, I don't know how to summarize the question. So he says that there has been a lot of investment done by the commercial tools. Shouldn't they stick to that to jump on that bandwagon? Or being different, is that a good idea? The thing is, I think they didn't do the right innovation in the right direction because they always had to keep up with Moore's law until now. So they really had to always jump along all the guys to work on getting their tools ready for the next node, and they hadn't time to reflect on how can we make the language and the structure better of everything. And I think open source can do that. They can do it at their home. So we should have this in parallel, and we should have interoperability. That's no problem, but I think that's possible.
Sorry, you need to
Yeah.
continue later if you want.
Yeah.
So
okay.
let's
Yeah.
thank Staff again.
Yeah.